story so far. When the degree of hotness or temperature of something goes up, its molecules go faster and it expands. This expansion can therefore be used to measure temperature itself. A device which does this is called a hotness meter or thermometer. On the Celsius scale thermometer, the level to which mercury contracts at the freezing point of water is labeled 0 degrees Celsius, and the level to which mercury expands at the boiling point of water is labeled 100 degrees Celsius. And now, temperature versus heat. Here's a bucket of hot water at 50 degrees Celsius. And here's a cup of freshly boiled water at 100 degrees Celsius. In which of these two containers are the water molecules moving faster? The bucket or the cup? That's right, because the degree of hotness of the water in the cup is much higher than the degree of hotness of the water in the bucket. And the hotter something is, the faster its molecules move. Would you say, therefore, that there's more hotness in the cup than in the bucket? In that case, if the water in your swimming pool is just a bit too cold for you, you'd be better off emptying the cup full of boiling water into it, rather than the bucket full of water at the lower temperature, wouldn't you? Or would you? You don't seem so sure. Let's do an experiment to find out. Suppose you had two identical swimming pools, one yellow and one blue. And suppose that the water in both of them was just a bit too cold for you. When you pour the cup of boiling water into the yellow pool, does the water feel any warmer? You can hardly feel any difference at all, can you? Now pour the bucketful of 50-degree water into the blue pool. How does that feel? Quite a bit warmer? Aha! So even though the water in the cup was considerably hotter than the water in the bucket, the 50-degree bucket water is much better at heating up swimming pools than the 100-degree cup water. Why is this? Well, let's look at the facts. The bucket obviously contains many, many more water molecules than the cup does. The temperature of the average molecule in the bucket is 50 degrees, and the temperature of the average molecule in the cup is 100 degrees. Now let's substitute something else for the molecules. Imagine that instead of molecules, the cup were filled with $100 bills, and the bucket with $50 bills. Which would you rather have? Each individual bill in the cup is worth much more than each individual bill in the bucket. But the total amount of money in the bucket is much greater than the total amount of money in the cup. It's the same with hotness. The degree of hotness, like the value of the dollar bills, is higher in the cup. But the quantity of hotness, like the quantity of dollar bills, is greater in the bucket. We know that it's the speed of the molecules that determines the degree of hotness of something. In fact, degree of hotness only depends on speed. It has nothing to do with how many molecules there are. Although the molecules in the bucket aren't going as fast as in the cup, there are more of them, so they more than make up in mass what they lack in speed. And it's mass, combined with speed, that determines quantity of hotness. We've already seen that the word for degree of hotness is temperature. Now it's time to introduce the other word for quantity of hotness, which is heat. The big difference between temperature and heat is that temperature depends on speed only, whereas heat depends on both mass and speed. The water in the cup has got a high temperature, but very little heat. And the water in the bucket has got a much lower temperature, but a great deal of heat. Now you know why buckets of 50-degree water are better at heating up swimming pools than cups of boiling water. On the other hand, if you're looking for somewhere to dunk your tea bag...